So there's going to be a review for the test tomorrow, which is on sections 8.5 to 8.9, and which is all about factoring. We're going to jump right in with these three questions. I hope you guys have written them down already. And we're going to begin factoring by applying the first type of factoring that we learned. What's the first type of factoring that we ever learned? Greatest common factor, GCF. And if you forget, check it out. There's a picture of the board, and it tells you, obviously the goal is to be able to factor any polynomial using different factoring methods, but the success criteria is pretty much telling you what different types of factoring methods we learned. We first learned how to factor out a GCF, and then after that we learned how to do factoring by grouping, and so on and so on. So you have all these methods on the board. So even if you're lost, you'll be able to look at the board and figure out what to do, hopefully, all right? If you're paying attention right now instead of talking, right? Once again, number one, we're going to pull out the GCF. So everybody put parentheses right below it. And what could you pull out of both the 8 and the 28? Could we pull out an 8? 8 times 1 is 8, but 8 times what is 28? No, that didn't work. 4, right? 4 you can. So let's pull out a 4. And again, 4 times what is 8x? 2x. 4 times what is negative 28? Negative 7. And that's it, right? And of course, if you struggle with multiplying, get a calculator and you could figure that out. Let's also do number 2 using the GCF, pulling out the GCF. So let's put parentheses around or below number 2. And we are going to pull out, what could we pull out? Let's think about the number first, the 12, the 18, and the 54. Well, I know they're all even numbers. I could pull out a 2, but the question is there a greater value than 2? 6. Excellent. 6, right? 12 is divisible by 6, 18 is divisible by 6, and 54 is divisible by 6. So I am going to pull out a 6, but how about, are there any letters that I could also pull out besides the 6? X's. How many X's could I pull out? 3. Total of 3. Okay, so again, the question is how many X's from all 3 terms could I pull out? Well, there's 9 here, 3 here, 5 here. I could pull out a maximum of 3 from all of them at the same time. Okay? So if I do pull out a 6x to the third, what's left? 6x to the third times what gets us back to 12x to the ninth? 2x to the sixth. And if it kind of confuses you, you could think of the numbers first, like 6 times what gets you 12? 6 times 2. And then you could think of the letters x to the third times how many more x's to get to the 9. Remember that you add the exponents when you're multiplying. So yeah, 6 more to get to 9. So over here, 6x to the third times what? Let's start with the number. 6 times what gets us a minus 18? Negative 3. Excellent. All right. And then how about x to the third times what gets us x to the third? Well, x to the third times 1 gets us x to the third. But it would be kind of silly to put a times 1 right there because it's not going to change anything. So don't do that. Let's just not do anything. Let's leave it a minus 3 in the middle. How about the last one? 6x to the third times what gets us 54x to the fifth? Let's start with 6. 6 times 9, yeah, is 54. So plus 9. And how about those x's? X to the third times how many more x's to get to x to the fifth? x2, x to the second. And ladies and gentlemen, we have factored, right? So you always try to pull out the GCF. That's the first type of factoring method that we learned. That's the first type of factoring method you're supposed to always try. Of course, you look at the inside and see if you could do anything else, but you can't. Let's move on to the next one. It's funny because we started with 2 terms, and we pulled out the GCF. 3 terms pulled out the GCF. We now have 4 terms. So what's the GCF on that one? 4, 4, no, not 4. Oh, 5, 5. No, we can't. We can't pull out a GCF, not even X's, right? Or Y's. We can't pull out a I can't even speak right now. Greatest common factor. Can't pull out a GCF. So what do? We look at the board again. Check it out. What was the next thing that we learned after factoring out the GCF? We learned how to factor polynomials by grouping. Okay, so that's what we're going to try next. Now, what does that mean, grouping? Well, if you can't pull out a GCF, maybe by separating them into 2 groups, 12x squared minus 4x y, and then space plus 15x minus 5y. Now that you have 1 group, 2 groups, they're separated, maybe you could pull out a GCF from that first group now. So what would the GCF of the first group be? 4 with an x. What would be left on the inside? 4x times what gets you back to 12x squared? 3x, okay? And how about 4x times what gets you back to a negative 4x, but with a y? A negative y. You can put a negative 1y. I like to put just y instead of a negative 1y. And then let's try to factor out of the second group. What could I pull out of the second group? A positive 5. Yeah, that's right. And if I do pull out that positive 5, 5 times what gets us positive 15x? 3x. Too easy. How about 5 times what gets us back to a negative 5y? Negative 1y. Negative 1y or just negative y? Okay, negative y. You could put negative 1 if you want, but I'm just going to leave it as negative y. Anyway, we do have a common binomial. 3x minus y here, 3x minus y here. We're going to pull out that blue common binomial, 3x minus y. So I want to put some exaggerated parentheses right here. I'm going to take out the common binomial 3x minus y. And if I do pull out the 3x minus y, I'll have a 4x left over. So I'll have a 4x right here. And if I pull out that 3x minus y, I'll have a plus 5 left over. So you put the plus 5 right there. And we're done. We factored it. Of course, let's write it with the correct size parentheses. When you type it in as an answer on the quizzes, you have to put it with no spaces. So parenthesis 3x minus y, no spaces, close parenthesis, open parenthesis, 4x plus 5, no spaces, close parenthesis. Do you get it? So on this page, on these 3 questions, all we did were the first 2 types of factoring right here on the board, factoring out the GCF and factoring by grouping. Of course, there's other methods, but that's how we do these first 3. Okay, let's move on. On this next page, we have 3 questions that they're asking us to solve. All right, so keep in mind, if they ask you to factor, what they're asking you is to rewrite your answer in factored form, which is kind of like having the answer and wanting the multiplication question. But right here, they're saying solve. And we could only solve equations. So when you solve, you actually want answers like x equals 5, x equals negative 3, x equals 1/2. So how do we solve equations? Well, back in semester 1, we would say simplify first and then get x by itself. How do you get x by itself on one side? By getting rid of things. To get rid of something, do the opposite. What you do to one side, do to the other side. But right here on this section, we know that it's very important to apply the zero product property. What is the zero product property? That if you have something times something and it equals 0, then you're able to split them and set them each equal to 0. So this guy right here, it's already ready to split and solve, okay? Because on number 4, we really do have something times something equals 0. So the first something, the x plus 3, that could be set equal to 0. And the second something, the 3x minus 2, that could also be set equal to 0. So you really have these 2 simple problems that you could solve. This one's super easy. What's the answer going to be right here when I subtract 3 on both sides? It's negative 3. X equals negative 3. I didn't show my work because it's so easy. This other one, I want to show some work. Plus 2, plus 2. I now have 3x by itself equals 2. Final step would be to divide by 3, divide by 3. And there's my answer. X equals 2 divided by 3. And those are your 2 answers for number 4. What do you think? And there's going to be a question like this on the test. It's already ready to split them and solve. Something times something equals 0. The first something could be 0. The second something could be 0. Okay. So we have another equation right here. Oh yeah, by the way, when you type it in on your Chromebooks, make sure you type in no spaces, x equals negative 3, comma, no space, x equals 2/3. Okay. No spaces between your terms. Put a comma between your answers. Okay. Number 5, we have another equation. But right here, it's not equal to 0. It's equal to 24x. So we don't want equal to 24x. We want it to be equal to 0. Why? Because we want to use the zero product property, okay? So let's first start by subtracting 24x and subtracting 24x. That way, you really will have equals 0 because that canceled out. On the left side, you can't really do this because you can't take away x's from x squares. They're not the same type of x. So all you could do is rewrite it. 8x squared minus 24x. Okay, so now we have it equal to 0. And now what do I do? Well, why do I want it equal to 0? Because I want to have something times something equals 0. And I don't have something times something. I have something take away something. So how am I going to get multiplication from this binomial? Anybody? How am I going to get multiplication from this binomial? Factor out the GCF. That's right. So let's put parentheses right below it. What is the GCF of 8x squared and minus 24x? 8x. Excellent. So let's put an 8 and an x. Now, if I do pull out an 8x, what's left over on the inside? 8x times what gets you back to here? X, okay. So you have x. And then 8x times what gets you back to negative 24x? Negative 3. Man, you guys got this, right? So all we've done is change this binomial to look like this factored form, 8x times x minus 3, okay? Now, why do I want 8x times x minus 3? Because if you have something times something equals 0, then the first something, that 8x, that could equal 0, and the second something, x minus 3, that could also equal 0. And it becomes two easy problems that you could actually solve, okay? Now, I am running out of space here, so I'm just going to write my answers. What is my answer to this one when I divide by 8 and divide by 8? What's my answer? X equals 0 divided by 8. What's that? 0. And the other one, if I go plus 3, what do I get? X equals 3. And those are your two answers. And again, type them with a comma with no spaces between your terms. X equals 0, comma, X equals 3. Let's move on to number 6. Number 6, also an equation. You want to solve it. When you have an equation, especially in this chapter, you want to make it equal 0 so we could factor to be able to split it and solve it. So let's get rid of that 60. How do I get rid of the 60? There you go. Subtract it, minus. We do to one side, do to the other. You can't really subtract 60 from x's or from x squares, so you're just going to rewrite the whole thing. It's going to say x squared minus 7x minus 60 equals nothing, okay? And now we have a quadratic trinomial. You can't pull out a GCF, but how do we solve, or how do we factor quadratic trinomials? Again, we're going to kind of pretend that this equals 0 is not there, and I want to factor this guy right here. So how do we factor quadratic trinomials that don't have a number in front? Well, if you totally forgot, look at the board. Yeah, let's look at the board. Let me bring it up. Okay, here it is. So if we look, we already did the GCF. We did factoring by grouping. Look down here on this last one. It says, know how to factor x squared plus bx plus c when there's no number in the front. See, there's no number in the front. So what do we do? What do we do when there's no number in the front? It says on the board to use this format, parenthesis, parenthesis, xx. So let's do that. Parenthesis, 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 xx. Okay? And then what? And then it says, think what times what is c that if you combine together gives you b. So what times what is this c value that if you combine together is this b value? What times what is negative 60 that if you add together is negative 7? So I always say make a list, right? So I'm going to make a list of the multiples of negative 60. So negative 1 times 60, negative 2 times 30, negative 3 times, and if you're totally lost, get a calculator and go negative 60 divided by negative 3, it'll tell you 20. 60 divided by negative 4, it'll tell you 15. 60 divided by negative 5, that'll be 12. 60 divided by negative 6, that'll be 10. And that's all the possible combos, right? So again, the question becomes what times what is c that if you add together is b? So if you just started combining these, what is 60 plus negative 1? That'd be a 59. That middle value is not 59. 30 take away 2 is 28. That's not a 28. 20 take away 3 is 17. That's not a 17. 15 take away 4 is 11. That's not 11. 12 take away 5 is 7. That is a 7, right? But it's negative, and you want it to be, well, you want it to be negative. So when I add these guys, it gives me a positive 7, but I want it to be a negative 7. So I have the right number, just the wrong sign, which means I have the right numbers, just the wrong signs. So go ahead and change it, okay? And now you could actually plug in that positive 5 right here and that negative 12 right there. And we have factored this quadratic trinomial, okay? Now, it's still an equation that's equal to 0, so it's still equal to 0. But now it's beautiful. Why? Because I have something times something equals 0. That means that the first something, the x plus 5, that could equal 0. And you already know the answer is going to be x equals negative 5. And the other something, the x minus 12, that could also be equal to 0. So you solve these two easy problems and you'll get your two easy answers. X equals what? Negative 5. And x equals what? 12. And just put a comma between them. Type them in like that. And you'll get full credit. Pretty good, huh? Okay, so when it says solve, that means you're dealing with equations. That means you want answers. If it says factor, then that means you want parentheses, okay? Let's go back to factoring, okay? So these are not equations. We're not going to have x equals or n equals 5 or anything like that because it's not an equation that we're solving. It's factoring. Factoring is a reverse distributive property. So I would like you to copy down these three. I want to pause it and then I'll start up in a bit. Do you guys think these are easy? These three are easy, or are they tough? If you're like, I have no idea what the heck to do, okay, look at the board. All right, so we already pulled out the GCF, and obviously that's not happening here. There is no GCF on all those. It's not factoring by grouping. So if you go down the list, you're going to see at this point right here, know how to factor ax squared plus bx plus c when the a value is 1, when there's no number in the front. All you do is set up parenthesis, xx, and then you think what times what is c, that if you add together is b. It's written on the board. It tells you what to do. None of these three have an a value of 1, a value of 2 or 5 or anything. They're all 1. There is no number in the front, right? No number in the front, no number in the front, no number in the front. So what does that mean? That means that all of these I'll be able to set up like this: parenthesis, n, parenthesis, z, parenthesis, x, right? Why, you might ask? Well, because x times x is x squared. Well, because z times z is z squared. Because n times n is n squared. That's why we're able to set this up. Now, if you had a 4, like a 4 right here, or an 8 in front of the n squared, then you wouldn't be able to set this up, okay? But anyways, because there's no number in the front, we could set it up for all of them. Now we think, what times what is the c value that if you combine together is the b value? Make a list. What times what is 28 that if I combine together is a -3, okay? Let's make a list. 1 times 28. 2 times, if you don't know, get a calculator and go 28 divided by 2, that's 14. 28 divided by 3, not going to work. 28 divided by 4, that'll be a 7, right? If you don't know, use a calculator. 5 won't work, 6 won't work. Those are the 3 possible options: 1 and 28, 2 and 14, 4 and 7. Out of these combos, which combines together to give you the middle value -3? Some of you might think, oh, if I change the 7 to a -7, then it'll work. But see, I don't recommend you. Look, this is what you should do. Just go to your list and start adding. What is 1 plus 28? 29. Is that a 29? No. What's 14 plus 2? 16. Is that 16? No. What's 4 plus 7? 11. Is that 11? No. So what does that mean? That this is not factorable. No se puede hacer. NF, not factorable. You could also write prime. You could actually write out the words not factorable. NF, any one of those will be acceptable. But the process remains true. Whenever you have no number in the front, do the parentheses, set up n, think of the multiples of 28 that combine together to give you -3. Now back to some of you might be thinking, well, why not just change that to a -7? Well, -7 times 4 is -28, not a +28. You see, the list came from the multiples of 28. So your list has to be it has to multiply to give you 28. So it's either 1 times 28 or -1 times -28. So if it's positive, they both have to be either positive or they both have to be negative. You can't just magically change one of them to be negative. I hope that makes sense. So yes, to conclude, when you switch signs, you cannot just switch one sign. It has to be both signs. So maybe like if this would have been a -28, then this would have been a -4 and a +7. And if you wanted to switch it, you could make it a +4 and a -7, right? But right here, it was 28, so they were both positive. So the only option is to change it to both negative, but that's not going to make it a -3. So that's why this is not factorable. So whenever you change a sign, it has to be both signs, okay? Whatever they are, you change the signs. Let's look at number 8. Once again, what times what is C, that if I combine together is B. Let's make a list of the multiples of 30. 1 times 30, 2 times 15, 3 times 10, 4 times doesn't work, 5 times 6. I would just say start adding them, right? Check it out. What is 1 plus 30? 31. Is that 31? No. 15 plus 2. 17. Hey, that's a 17. That's good, right? But 2 and 15 is +17, and we want it to be a -17. So we have the right number 17, just the wrong sign, which means that we have the right numbers, just the wrong signs. So how am I going to change it? I'm going to change both signs. That +2 becomes negative. The +15 becomes negative. So I will have a -2 right there and a -15 right there. Boom, it's factored. Let's do the next one. Check out how easy it is. What times what is negative 24 that if I combine together is negative 5? Let's make a list. Negative 1 times 24. Negative 2 times 12. Negative 3 times 8. Negative 4 times 6. Negative 5 doesn't work. That's it. Just start adding them. What is 6 minus 4? 2. That's not a 2. What's 8 minus 3? 5. 8. That's a 5, but I want it to be negative. So what do I do with the signs? Change them. You see, because 8 plus negative 3 is positive 5, and I want it to be a negative 5. That means I have the right number, the wrong sign, which means I have the right numbers, just the wrong signs. So these are my numbers, but change it and change it. You're not always going to change it. It just depends on the sign of the middle term, right? So right there, we had to change them. All right, anyway, we're going to have x plus 3 and x minus 8. There it is. It's factored. So I hope you guys understand that. But what happens when we get to number 10? You know what? 10 and 11. Copy both of those down, please. I want to pause it, and then I'll explain it. Let's begin with number 11 before 10. I'm going to go a little out of order here, okay? So how do I do number 11? Well, let's look at the wall again, the board. We already tried pulling out the GCF. Actually, let's try pulling out the GCF. It's a great idea to always start with that. Is there a GCF with 6, 11, and 10? No, there isn't. Okay, you can't even pull out X's. You're definitely not going to do grouping. It's not 4 terms. It's only 3 terms. I wish there was no number in the front. That way I could do this. But there is a number in the front. The number is 6 in this case. So obviously, I can't use this method. But if I look up here at the board, up here it says, know how to factor ax squared plus bx plus c when a is not 1. Okay, well, this is a case where a is not 1. And if we zoom in, right there in blue, it kind of gives you hints at the steps. Step 1, a times c, get a number. Step 2, list of the multiples of that number. And then step 3, make the format ax, ax. And step 4, divide. I hope we remember that. It's on the board. So that's what I'm going to do right here. I'm going to start with step 1, multiply a times c, where a is 6 and c is negative 10. A times c is negative 60. Step 2, make a list of the multiples of negative 60. Negative 1 times 60, negative 2 times 30, negative 3 times 20. And if you don't know, just get 60 divided by negative 3 on a calculator and it'll tell you 20. 60 divided by negative 4 on a calculator, it'll tell you 15. 60 divided by negative 5, it'll tell you 12. By negative 6, it'll tell you 10. And those are all the possible combos of multiplying numbers together to give you negative 60. So now which of these numbers will combine, not multiply, will combine to give me the b value negative 11? That's exactly right. If I combine minus 4 plus 15, that'll give me a positive 11. And I do have an 11, but I want it to be a negative 11. So I have the right numbers, just the wrong signs. Change it, change it. So when we now have the answer for step 2. What is step 3? Step 3 is to use the format ax, ax. It's on the board. Okay, you're going to have this on the board tomorrow. So let's do this. Parenthesis, 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 ax, ax. What is a? Well, you could see that a is right here. A is what? 6. And of course, it does have the letter x. You might have p squared and you would put 6p. You might have 6q squared, you put 6q. But right here, it's 6x itself. So put that right here, 6x, 6x. Then you take the pair of numbers from step 2 and just put them right there in those blank spots. That plus 4 and that minus 15. And now it's factored. However, it's still not correct. We still need the fourth and final step. What is the fourth and final step? Fourth step is to divide, as you could read it on the board right there. So divide this binomial by whatever you can. It's kind of like pulling out the GCF without actually writing the GCF on the outside. I could divide both 6 and 4 by what? By 2. What is 6 divided by 2? 3x. And what is 4 divided by 2? 2. How about the other one? Could I divide both of these by 2? No, by 3, right? What's 6x divided by 3? 2 with an x. How about 15 divided by 3? Negative 5. And we're done. This is as long as a problem could get. I mean, unless it's an equation, then you would have to split them and solve afterwards. But I mean, if you understand that, that's great. And it's written on the board. Even if you don't understand, you could read it off the board and hopefully get it. So look at number 10. The reason why I did 11 before 10 is because when we look at 10, you might be tempted because you're like, oh, there's an a value of 3. So I cannot do what I did before, I can't do this. Why not? Because there's a 3 out there. Okay, so you might jump straight into doing A times C, but the reality is you don't want to go A times C. Yes, there's a greatest common factor. Thank you for recognizing that. So start with the very first type of factoring we ever learned. Always try to factor out the GCF. Okay, so when you factor out the GCF, look how easy it becomes. You could pull out a 3. And if you do pull out a 3, what do I have left on the inside? All 3 terms. X squared plus 5x plus 4. Perfect. Now, if you look at the inside, just that blue quadratic trinomial, that blue quadratic trinomial does not have a number in front anymore, which means you could go back to setting this up, xx, and then think what times what is the c value for that if you add together is 5. The only way you're going to get 4 is 1 times 4 or 2 times 2. Which pair of numbers works? The 1 and 4, right? So plus 1 plus 4. You factored it. Don't forget about your outside 3, this 3 that you originally pulled out as a GCF. Bring that down, put it in front. There's your completely factored form answer. You did not have to do the 4 steps that we did on number 11. Are you with me? Excellent. So always try to pull out the GCF first. Why? Because it makes everything easier. You might be able to continue factoring on the inside. Okay, we are almost done. There's only one more section up here. Give me a second. One more section right here of factoring. Okay. Now, what kind of factoring could I apply on number 12? We may need to look at the board again, right? All right, so I want to keep the question up there. So I can't pull out a GCF because there's nothing in common in 4 and 81. I'm not going to do factoring by grouping. Obviously, this is not a quadratic trinomial, not a quadratic trinomial. We technically are right here on the last part, know how to factor perfect square binomials and trinomials by applying square roots. The question is, do we have a perfect square term in the front and a perfect square term in the back? Yes, we do. So because this is a perfect square and because that's a perfect square, I could attempt to just plug it into my factored form answer format by taking the square root of 4x squared. What's the square root of 4x squared? 2 with an x. And you put that as the first term of each of those binomials. And then what's the square root of 81? 9. So you put that as a second term of both binomials. And here's the question. What kind of 9 times what kind of 9 will give you a negative 81? One positive, one negative. They have to be different. They both can't be positive. They both can't be negative. As a matter of fact, guys, the only time you're able to do this is if it's a difference of 2 perfect square terms. Let me repeat that. The only time you could actually square root and use this shortcut is if you have a minus sign in between the 2, okay? Because that is when you end up with different signs, 1 plus 9, 1 minus 9, and that positive 9 times negative 9 will give you the negative 81. But not only that, when you distribute completely, the middle terms will cancel out, right? So if you go 2x times 2x, you get the 4x squared. 2x times negative 9 is negative 18x, but then positive 9 times positive 2x is a positive 18x. So the negative 18x and the positive 18x disappear, which makes it a binomial, not a trinomial. So very important, you need a minus sign between your 2 perfect square terms to be able to square root them and put 1 plus 1 minus, okay? Number 13, are these perfect square terms? No. So what type of factoring should I do? GCF. Always try to do the GCF first. What is the GCF of 32x squared and minus 18? 8 times what is 8? 9? 9? 9 times? No, not 9. At the very least, they're both even numbers, right? What could I pull out of even numbers? A 2, right? Bless you. So we're going to pull out that 2. What's left over on the inside? What's half of 32? 16 with an x squared. Half of 18? 9. And now some of us might submit this as an answer and get it wrong. Why? Because look at the inside of the parentheses. You could continue factoring. Yeah, this is a difference of 2 perfect square terms. So you're going to be able to, first of all, bring down the 2 and then go parenthesis, 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 and then actually do the square root of that guy, which is 4x, and the square root of this guy, which is 3, and 1 plus 1 minus, or 1 minus 1 plus. But you have to type in this entire thing, 2 parenthesis 4x plus 3, close parenthesis, open parenthesis, 4x minus 3, without any spaces between your terms. Last but not least, number 14. What could I do there? Okay, is there a GCF? No, can't pull out a GCF. Are they perfect square terms? Yes. But if you actually take the square root of them and you try to plug them into your factored form format, it's not going to work because it doesn't have a negative. That's a positive. So that's a big no-no, right? There is no way that you're going to be able to factor this. This is simply not factorable. Not factorable. So you can put NF, you can put prime, you can put not factorable, but you cannot factor this. Like, let's say you said, oh, I'm going to square root it. I want to square root it, get a 3x, and the square root of 49 is 7, 3x and 7. And then you're thinking about what belongs right here, what sign, what kind of 7 and what kind of 7. Well, how are you going to get positive 49? It has to be a positive 7 times a positive 7 or a negative 7 times a negative 7. But either way, the middle terms will not cancel out. And you end up with a trinomial, not a binomial. So it simply does not work. You have to have a minus sign for you to be able to use the shortcut method. If we look at number 15 here, that is also a perfect square quadratic trinomial. Perfect square in the front, perfect square in the back. So you could jump straight into that factored form answer format, which would be parenthesis, 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 and do the square root of that perfect square term. So what is the square root of 36x squared? That's 6x. So you put a 6x on both of those. And you look at this one, that's also a perfect square term, which you could do the square root of 49, which is a 7 and a 7. And then you just got to think of the signs right here, right? Right here, in order to get a positive 49 at the end of your distribution, what kind of 7 times what kind of 7 will give you a positive 49? They're either both going to be positive 7s or both going to be negative 7s. So how do you determine if they're both positive or if they're both negative? The middle term is negative, which means that these have to be both negative. Because if they were positive, then the whole thing would be positive, and that would be positive as well. So just think about that. The signs have to be the same, and in this case, they're both negative because that middle term is negative. And that's about it, guys. All right, if you understand this, you'll be ready for the test.